Hi students, my name is Emma Reed. I am an 8th grade math teacher, and today we are continuing our work in Unit 8, the Pythagorean Theorem and Irrational Numbers. Today, day 6, we are answering the big question, what is an irrational number? Our launch for today, on slide A, asks us, are any of these numbers listed a solution to the equation x squared equals 2? So you're looking at each of the choices. We have 1, 1/2, 3/2, and 7/5. Are any of those a solution to x squared equals 2? Pause and think about that question. Write your answer in the blue space. When you've had enough time to think about your launch, move ahead with me to slide B, where we're going to talk about rational numbers. So you might have heard the term rational or irrational before. Maybe you've had someone in your life call someone else irrational if they're trying to accuse that person of not making any sense. So when you read this in a book, right, rational means logical, makes sense. Irrational can mean illogical, not making sense. So anything that's irrational is not rational. So if we want to understand what irrational means, it's really important that we know what rational means. So in math, rational numbers can be defined like this. And read along with me silently. A rational number is a fraction or its opposite. Remember that a fraction is a number on the number line that you get by dividing the unit interval into b equal parts and finding the point A that is a of them from 0. We can always write a fraction in the form a over b, where a and b are whole numbers, and b is not 0. But there are other ways to write them. For example, 4/10 is a fraction because it is a point on the number line that you get by dividing the unit interval into 10 equal parts and finding the point that is 4 away from 0. You get the same point if you divide the unit interval into 5 equal parts and find the point that is 2 away from 0. When we first learned about fractions, we didn't know about negative numbers. Rational numbers are fractions, but they can be positive or negative. So -2/5 is also a rational number. So now that we've refreshed what the idea of rational numbers are, keep in your mind, well, what would make something not rational? And that's something we would call irrational. Move ahead with me to slide C. On slide C, we have some examples of rational numbers. So any of these numbers can be written as a fraction, a over b, can be positive or negative. So on the number line below, indicate the appropriate location for each of the rational numbers listed. I'm going to read the numbers we're working with out loud, and I encourage you to get in the habit of thinking about how to correctly say numbers because it can help remind you of their meaning. So we have 7/4, 0, 6/3, 2/10, -1/3, -5, the square root of 9, and then we have negative the square root of 16 over the square root of 100. So on the number line below, indicate the location for each of those numbers. And I suggest start with the friendliest number. Which ones are you the most confident about? And then narrow it down using what's friendliest first. Pause and think. Take your time to order these numbers. Now we'll move on to slide D. And we're going to think back to slide A. So on slide A, we examined some numbers that were close to the square root of 2. Find some more rational numbers that are close to the square root of 2. So look back at slide A. What from slide A could help you think about this question? Pause and think. And when you're ready, put some of your ideas in the blue space. Next, we'll move on to slide E. On slide E, it asks us this big question: can we find a rational number that is exactly the square root of 2? So your answer is either going to be yes, we can find a rational number that is the square root of 2 because, or no, we cannot find a rational number that is exactly the square root of 2 because. Pause and answer this in the blue space. And when you're ready, we'll move on to slide G. So on slide G, the big reveal, the square root of 2 is not a rational number. So we haven't learned enough yet to prove for sure that the square root of 2 is not equivalent to a fraction. In the future, during your study of math, you will have an opportunity to explore proofs that show the square root of 2 is not rational. For now, we just have to trust that there are numbers on the number line that are not equivalent to a fraction, and that the square root of 2 is one of them. However, it is possible to get very close estimates with fractions. Moving on to slide H. Now we're going to talk about irrational numbers. So an irrational number is a number that is not rational. That is, it is a number that is not a fraction or its opposite. The square root of 2 is one example of an irrational number. It has a location on the number line, and its location can be narrowed down. It's a tiny bit to the right, meaning a tiny bit greater than 7/5. But the square root of 2 cannot be found on a number line by subdividing the unit interval into b parts and taking a of them. We have to define the square root of 2 in a different way, such as the side length of a square with an area of 2 square units. Moving on to our final slide, which is our summarize section, slide I. To prepare for this summary, record your response to the focus question. What is an irrational number? And you want to make sure that you describe this in your own understanding, in your own words. Pause and take your time to answer that question. On the right, use that space to record notes. I strongly suggest that you put some notes down about what the difference between rational and irrational numbers are, since it's really important. We can tell it's in the title of our whole unit. Thank you for joining me today, and have a beautiful day.